Okay, Assalamualaikum warahmatullahi wabarakatuh and hi. Today I'm teacher Hidayah from SMS Hulu Selangor. Will teach you about chapter 6 form 4 KSSM, which is linear inequality in two variables. Okay, there are two subtopics that we will cover for the whole topic. The first one we'll learn about 6.1, which is linear inequality in two variables. Okay, and next part we'll cover about 6.2. So this part only we will cover 6.1, right? Okay, so here are the notes, and you notice here you have four famous symbol notation. Alright, so the first one we do have more than or greater than, yeah. So this part, yeah. So usually let's say we have more than 5. Let's say if I have an example, or greater than 5, yeah. So what do you understand about more than 5 or greater than 5? So that means you are looking for the value more than that, not 5, yeah. So that's why the equal sign is not included in this notation. Okay, and then for the second notation we have less than. So let's say you have less than 5. So that means you are looking for the number less than that. So that's why the symbol you have like this, yeah. Okay, and the third one we have the symbol you have more than, but then you have a little dash here, dash line. So that means we say this one more or equals to, at least, or not less than. So let's say if I have more or equals to 5, what do you understand about this one? So this one means that you are accepting 5 or more than that, the number, right? At least 5. So at least 5, that means we are accepting 5 and above that number. Okay, and then lastly, not less than 5, not less than 5. Okay, not less than 5, you are not accepting the number that less than 5, but you are accepting number 5 and above. That's why the symbol is like the third notation. Okay, and then for lastly we have less than or equals to. So if I take 5 as the example here, alright, so less than or equals to 5, that means you are looking for 5 and number below that. Okay, that's why the equal sign is included here in the fourth notation. At most 5, that means the maximum number is 5, So let's say at most, somehow we are saying the maximum number is 5, yeah. So 5 or below than that. And then lastly, not more than 5. So that means we are accepting 5, but we don't accept the number after that. So that's why it say not more than 5. So the symbol is like less or equals to. Okay. Alright, so let us look 6.1.1, represent situation in linear inequality form. Okay, the first one, Hakim buys 2 kilograms of chickens and 5 kilograms of rice pack. The total cost for both items is more than 50 ringgit. So here we have two variables. Okay, the first one we have chicken. Okay, so I'll show note this one as variable x, and then we have rice pack. This one I take as variable y. So we do have 2 kilograms of the chicken, so that means we have 2x here. Alright, and then plus we have 5 kilograms of rice pack, that means we have 5y here. So the total cost, so that means we need to add them both, is more than 50. So more than 50. Okay, so this one is the first answer of the inequality. We look at B. Participants who are allowed to join the sports, game and cooking competition are not more than 100 people. So here we have two variables also. So the first one we do have sports game, so I take this one as x, and second one we have cooking competition, I take this one as y. So we are not more than 100 people, so we don't know how many of them who join, so we take x plus y. Okay, what do you understand about not more than 100 people? Okay, not more than 100 people. That means we are accepting the 100. We can still accept, but the number more than that we cannot accept. So the notation will be less or equals to 100. Yeah. Alright, so this is for the second one. And then for C, Ali should obtain at least 20 marks for part A. So here the variable X, so 20 marks, so we have 20x here. Okay, and then plus the second one, 30 marks for part B. This one variable Y, so I have 30y. The passing marks is 50. Alright, at least, so it means Ali should get 50 and above. So the symbol will be 50 and above, greater or equals to 50. Okay. Alright, so 6.1 from point 6.1.2. Okay, we want to determine the or validate the conjecture about the points in a region, and then we need to solve. Okay. Okay, so first of all we need to learn what is conjecture here. Okay, so conjecture is a form an opinion or reach a conclusion on the basis of info that is not certain or not complete. So we do have something that is not certain, but we jump into a conclusion by doing testing. Yeah. So we look at the example here. Complete the table below to determine whether each given point satisfies the equation y equals to 5x minus 3, inequality y greater than 5x minus 3, or y less than 5x minus 3. So these are the table. Okay, the first point we look at here, we have the point 0, negative 3. What is the coordinate? So the coordinate is negative 3. Okay, according to the coordinate of y is negative 3, according to the point. Okay, and then we want to insert the value 5x minus 3. So we have 5 and then x bracket 0 minus 3. So here we have negative 3. Okay, so the coordinate here negative 3. So negative 3 is equal to negative 3. Therefore, what we understand about this one? Okay, it satisfies the equation. Okay, not the inequality but the equation, because you get same answer for both sides. So y equals to negative 3, left hand side 5x minus 3, also you get negative 3. Alright. Okay, so we try to do the next one. We have 0.14, so the coordinate of that is 4. And then 5x minus 3, we want to insert the value, so we have 5 bracket 1 minus 3. So 5 times 1 equals to 5. 5 minus 3 equals to 2. So in this case, we have 4 which is greater than 2. So the answer will be satisfy the inequality y greater than 5x minus 3 in this case. Because as we did in the example, we have 4 greater than 2 in this case. The next one, we have 0.310. So here the y coordinate is 10. And then we want to insert the value. So we have 5 times 3 minus 3. So that this one we get 15 minus 3. So we get 12. So we know 10 is less than 12. Therefore, it satisfies the equality y less than 5x minus 3. Because we have 10 less than 12. Okay. This is how you want to validate the conjecture. Okay, so we move on. Determine whether the following points satisfy the following inequality. Okay, look at this point 0, negative 5. So here we have we want to substitute y as negative 5, and then we want to substitute x as 0. So do we satisfy the inequality? We'll try to check this one first. Okay, is it negative 5 greater than 3 times 0 minus 2? We try. So negative 5, 3 times 0 equals to 0. So 0 minus 2. So negative 5 greater than minus 2. Is it correct? Not correct, right? So we cannot do like this. So therefore, the answer is not satisfy the inequality y greater than 3x minus 2. We move on to next example. Alright, so here y we have negative 2 and then x we have 1. Right, so we check. So negative 2 less than 3 times 1 minus 2. So negative 2 less than 3 times 1, you got 3 minus 2. So negative 2 less than 1. Is it negative 2 less than 1? Satisfy the equation? Of course, yes. Yeah. So satisfy the inequality y less than 3x minus 2. Okay, we move on to 6.1.3. Determine and shade the region that satisfy a linear equation. So here you are given two diagrams, the first diagram and the second diagram. What is the main difference that you can detect from this one? Okay, apparently the main difference is the line here. The first one here you have the dashed line, second one you have a solid line. That one is the first difference. Okay. Alright, so it says from the first diagram, straight line is drawn using the dashed line. What do you understand about the dashed line? The regions do not include the points that lie on the straight line y equals to mx plus c. That means if you have a coordinate here, somehow I will take this point. Let's say anything that point that lies within the dashed line here. For example, okay, this point, yeah. Okay, this point here, what is one? Negative 1. So I try to draw this one. Okay, negative 1, and then you have this one, negative 1, negative 2, negative 3. So the point negative 1, negative 3 not lies in the line because you have dash. It is not included in the region. Okay, whereas the second diagram, we have a straight line is drawn using a solid line. So what do you understand about solid line? Okay, any point that lies within the line, the solid line, is included in the region. Okay, let's say the same coordinate here, negative 1, negative 3 here. Okay, so you have negative 1 and negative 3. This point lies at the line, so therefore the region, the points is included in the region. Okay. Alright, and also from the notes you look at the region shaded, yeah. So here are the example. Shade the region that satisfy the following inequality. So this first one you have y greater than 3x minus 2. So where is the region shaded? Okay, so here you have the dashed line because you have the symbol greater not have the equal sign. That's why you have the dashed line here. Okay, if you want to find greater than, so you need to find the area above the line. So you draw an arrow here. So an arrow above the line that shows the shaded region like this. Okay, so next example, we have the dashed line also because we don't have equal sign of the notation inequality. So we are looking y less than 3x minus 2. That means you are looking for the region below the dash line. So here is the shaded region. Alright, so for C, we have greater or equals to. Because of the equal sign here, you have a solid line. So when you have y greater or equals to 3x minus 2, you are looking for the region above the line. So here is the shaded region. Okay, for D, we need to detect what is the region less or equals to. That means you are looking the value below the solid line. So here is the shaded region. Alright, so for E, so again here, what is the difference between the first example that we did before? Okay, this one, the gradient of x, you look at the gradient of x, this one is negative. So that's why you get the line like this. Okay, negative x. So that means negative gradient. Okay, so when y greater than negative 3x plus 2, so you are looking for the region above the dashed line. So here is the region. And then lastly, you are looking for the region less. So that means below the dashed line. So here is the shaded region. Alright, how about G? G is the same thing, because you have the negative gradient, and then you have the solid line because you have the equal sign here. So you are looking for greater or equals to, that means above the line. So here is the shaded region. And lastly, you are looking for the less or equals to, that means you are looking for the region below the line. So here is the shaded region. Alright, so thank you. So hope to see you in the next part.